So, what is a projectile? Well, a projectile simply means any object which has been launched or even dropped. Basically, it's an object in free fall. We've already met that idea in a simplified form. So it's an object where it's only acting under the influence of weight. That's the only force acting on it. No air resistance, we're neglecting that. No other ways of applying a force, so no engines, wings, anything like that. And what's this got to do with the video you should have just watched on Mythbusters? Well, in that video they fired a bullet, so that was a projectile, and they dropped a bullet, so that was a projectile. But one of the bullets was simply falling straight down at the exact same instant that the other one was firing sideways at very high speed. And what we found in that case was that both of them hit the ground at the same time. Now, what does that tell us? That tells us that the sideways motion doesn't affect the vertical motion. They take the same amount of time to reach the ground, to drop. Their vertical motion is identical. And that actually makes solving what's going on with projectiles much more straightforward. We can now simplify projectiles into working out what's going on with it vertically, what's going on with it horizontally. If I show you a wee simulation, basically of the same idea as the video that you just watched. So in this one I fire a cannon, and if you see, both balls hit the ground at the same time. Now, why is that? You've already seen. And it's because that sideways motion doesn't affect the vertical motion. The horizontal motion doesn't affect how long it takes to drop. Both of them are being pulled down at the earth at 9.8 meters per second squared. Right, we met that idea in free fall. If you drop an object, it will accelerate downwards at 9.8 meters per second squared. And we're seeing that this sideways one does the exact same. It's a wee bit clearer in this multi-frame image. Okay, if I reset and fire it again, what it's doing is it's showing you the position of the ball at regular time intervals. And what we can see is this one going sideways, it's moving along the way at fixed sideways intervals. But down the way, it's always at the same vertical position as the one that's simply dropped. So we can see that the vertical motion at all points in time is identical, and we know that that one accelerates down at 9.8 meters per second squared. Okay, remember we're neglecting air resistance. If we increase the speed at which it's going sideways, it doesn't matter. We saw that with a bullet. Okay, so if I go to the fastest possible speed and fire the cannon again, both of them hit the ground at the same time. And once again, if we look at the detail, the kind of multi-frame images, then what we see, right, is if you line up the vertical positions, then they're always at the same vertical position. Now, what's happening to it horizontally, it's a bit clearer in this one, I think, than the first one, is you can see that it's moving in equal horizontal gaps. The vertical motion is getting further and further apart gradually, so starting quite close together. That's because it's accelerating, it's getting faster vertically, so it's travelling more distance each time frame. But looking across the way, what we can see is its constant horizontal speed. So we can now analyse this kind of standard curve that most people, if you ask them, if you throw an object sideways, what's it going to do? They would trace out with their hand that sort of curve. And at Nat 5, we're only going to look at what happens when you launch something sideways. We're not going to bother kind of if you throw it up the way or at angles and so on. We're always going to be looking at it going sideways. And what we see is that the horizontal speed is constant because there's no horizontal force. We said the only force acting is the weight, which is vertically downwards, and that we've said that the vertical and the horizontal forces, motions don't interact with each other, they don't affect each other. So that weight has no effect on the horizontal motion, and the horizontal motion has no effect on the vertical motion as well. So that's the key idea we need to get from that video. Those two things are independent, and that explains a standard curve that you're probably used to, because it's made up of constant horizontal gaps, but increasing vertical gaps. Right? It's accelerating vertically, it's constant speed horizontally. We'll look at a couple of real life examples of that.